Okay, welcome back to the bootcamp. Now we move on to chapter 4. We have to do a lot of statistical testings on the multivariate regression. Okay, you actually learn virtually all of these statistical tests in your Eco 311 actually. And then I think I can mainly focus on the study guide, except for the slides. There are two things I need to point out. This is the first one. The sixth and the last assumption of the multiple linear regression model is featuring in this chapter. Okay, and then this assumption you actually learn it in Eco 242. It is about the error terms have a normal distribution. Remember, sometimes positive, sometimes negative random distribution. Okay, with a normal distribution, bell-shaped symmetric, and then with a mean of 0, and the variance of is equal sigma. I hope this is called sigma square. Okay. And then the second thing I want to point out from the slides is actually the last slide. Okay, how to present the regression output. I think I briefly mentioned in the very first lecture. Is it chapter 19 or chapter 1? Okay, it's not anything surprising that we run more than one regression, and then we put, let's say in this example, 3 regressions on log of salary. We put 3 regressions in column format, okay, all in the same table. So maybe in the first regression, I only include 1 explanatory variable, the second one. Now I add 2 more. And then the third regression, I add another 2 more additional explanatory variables, okay. So not anything surprising. We usually would run more than one regression. We play around with different, let's say, combination of explanatory variables. And then the third thing I want to talk about is actually on your prescribed chapters. Okay, page 138 of chapter 4. Okay, again, it refers us back to the economic significance and statistical significance, which I briefly mentioned. Actually, not briefly. Actually, I explain in detail in chapter 19 actually. So let me enlarge that. Okay. Check for statistically significance of the regression parameter. If it is statistically significant, then we also have to focus on the magnitude. Okay, so that we have an idea of the economic importance. Okay, so to refresh your memory, let's go back to the study guide of chapter 19. Do you still remember this example? Marks explained by study hours, having a WhatsApp study group, and then household income. Let me enlarge this. Okay. So this one, computer t-stat is very strong. Okay, then it is statistically significant. And it actually means the study hours variables definitely feature in the PRF. Okay, so statistically significant. And in terms of economic significance, it is significant. Look at the huge magnitude, 5.25, meaning when study hour increases by 1 unit, ceteris paribus, on average, the marks would increase by more than 5 points. So in other words, the study hour variable is both statistically significant and economically significant. And then the problem rather has to do with the WhatsApp study group variable. It is statistically significant, but the point is the economic magnitude is so small that we say it is economically insignificant. It means if I have a WhatsApp study group, then compare to this is a dummy, I keep that in mind. So if I have my WhatsApp study group, then compare with the reference category, meaning those who don't have a WhatsApp study group, my marks only increase by 0.1, okay? Then we say WhatsApp study group dummy is statistically significant, but economically it is insignificant because of the very small magnitude, okay? And then let's go back to the study guide chapter 4. So I actually am done with the first one. And if a variable is statistically insignificant, at least you can still check if this explanatory variable has the expected effect on y, meaning whether it has the correct sign. Okay, so if I go back to the example here, remember household income. If you still remember what I discussed under chapter 19, it is insignificant, but at least it has the correct magnitude. Okay, I come from richer background, financial background. Okay, then it will have, I come from a household with higher income, then I will have enjoy an advantage in my academic performance, although the household income variable is insignificant. Okay, I think I mentioned under chapter 19 that household income or the family background does have an impact on the children's performance, but we really don't have certainty that it is statistically significant because we really have some examples that some kids, they come from poorer backgrounds. Somehow they are very diligent. They obtain very strong academic performance. Okay, although in general, the direction of the relationship is more or less positive. Okay. And then if we go back to the study guide, we rather worry about this. What if an explanatory variable has an unexpected wrong sign? Okay, but somehow it is statistically significant, then you really have to worry about your regression. Do you commit some specification bias in your regression? Remember underfitting, overfitting, or did you use the wrong functional form? Okay, so if I go back to my Chapter 19 example, what if I have the following problems? Let's say for the study hours variables, what if this time you have a negative slope parameter? Okay, so it is statistically significant, but you worry about the economic magnitude. It is also economically significant, but it has the wrong sign. How would I, let's say a student studies 1 more hour and then the regression predicts that on average marks would decrease by 5.25, then there is an alarming bell ringing. Is there something wrong with your regression? Okay, maybe I definitely commit underfitting if that happens, because I should have included, let's say, lecture attendance, tutorial attendance, and so forth. Okay. Okay, so please go through page 138 of your prescribed textbook. Okay. To fully understand the difference between statistical significance and economic significance. Okay, and then I already discussed the 6th assumption of the multiple linear regression model on the error terms distribution. And then now the same old story. I think this is your favorite question. I don't know if you still like it or you start to feel bored with this type of t-test. It could be one test on one regression parameter, one-sided left tail, one-sided right tail, or two-sided. For two-sided test, I just want to refresh your memory in case you totally forgot how you passed your 2nd and 3rd year econometrics with flying colors. For two-sided tests, if we reject the null hypothesis if computed t-stat is greater than both critical t-stats, or if the computed t-stat is smaller than both critical t-stats. So we actually have 2 critical t-stats, because when we look for the critical t-stat, keep in mind the top row of the t-table gives you half of the alpha, and then the second row gives you your full alpha. And then after we successfully look for the critical t-stat, we have to add plus or minus sign so that there are 2 critical t-stats in total. So keep that in mind. One-sided right tail test, we reject the null hypothesis if computed t-stat is greater than the critical t-stat. There is only one critical t-stat. When you look for this critical t-stat, the top row of the t-table gives you your whole alpha. One-sided, remember, we have the whole alpha on the right-hand side of the graphical sketch, which we will show a bit later. And then for one-sided left tail test, everything is the other way around, just like the mirror image of one-sided right tail test. So for the one-sided left tail test, we reject the null hypothesis if computed t-stat is smaller than the critical t-stat. In addition, when looking for the critical t-stat, again, the top row of the t-table gives you your whole alpha, but please add the negative sign so that the critical t-stat is negative. In fact, your alpha is on the left-hand side of the graphical illustration. The computed t-stat equation is your sample regression parameter minus the hypothesized PRF population regression function parameter divided by standard error of the relevant parameter. Degrees of freedom n minus k minus 1. Remember, k stands for the number of parameters excluding the constant. The 1 stands for the number of constant, which is 1. Okay. Alpha must be either 1%, 5%, or 10%. Okay. So let's do a question. Okay. Marks explained by study hours, party hours. Sample size is 20. 2 parameters. This is actually B1, B2. Degrees of freedom, n minus k minus 1. So 20 minus 2 minus 1 constant. So 17. First one, two-sided test. Actually, for the bootcamp, I want to focus more on one-sided test, but let's do one question on two-sided test. So I want to know currently in the sample regression function, my B0 hat constant is a non-zero value. So I want to know would the same thing happen in the PRF. So in other words, test if the true B0 in the PRF is equal to 0 or not at alpha equals 5%. Okay, you should be happy with the first step. New hypothesis B0 is 0. B1, B0 is not 0. So two-sided test. Computer t-stat. B0 hat 45 point something minus B0, the hypothesized value 0, divided by standard error of B0 hat 9 point something. So your computer t-stat is 4.786. Critical t-stat, degrees of freedom is 17, alpha is 5%, two-sided. So let's look at the appendix. 17, two-sided, so top row gives you half of the alpha, 2.5%, second row, full alpha, 5%, 17, so isn't it 2.110? But remember, add plus or minus sign, so you have two critical t-stats, plus or minus 2.110. Okay, then graphically, you see the computer t-stat is greater than both critical t-stats. So this is step 4, therefore the new hypothesis is rejected. Then it means in the PRF, your true B0 is also a non-zero value. So step 5, the new alternative hypothesis would happen, meaning when all your x's, study hours and party hours, both equal to 0, then on average, final mark would be a non-zero value in the PRF. Okay, let me stop for 10 seconds for you to go through the graphical sketch one more time. Okay, happy with that? Then the test on B1 currently in the sample regression function, my B1 hat is positive. It conforms with economic theory, positive relationship between study hours and marks. So I want to know would the same thing happen in the PRF. You spot the keywords greater than 0. Alpha is 1%. Step 1, you should be fine. Step 2, computer t-stat. I think is equal to B1 hat. 5.62 something minus the hypothesized PRF value 0 divided by standard error of B1 hat 2.1779. Then you get your computer t-stat 2.5837. Critical t-stat 17, alpha is 1% one-sided, so the top row of the t-table gives you your full alpha 17, so 2.567. Okay, and then the computer t-stat is barely only just greater than critical t-stat because 2.58 is greater than 2.567. So computer t-stat is greater than critical t-stat, we reject the new hypothesis. I don't do the graphical sketch, I want you to do it on your own this time. So meaning H1 will take place, meaning when study hour increases, providing there's no change in party hours, remember the ceteris paribus condition, on average, final mark would increase in the PRF. So once again, meaning in the PRF, the true B1 would also be positive. Then the last one, currently in the sample regression function, B2 hat is negative, so it means negative relationship between party hours and marks. Now I want to know would the same thing happen in the PRF. So I need B2 hat and standard error of B2 hat. So this is the answer. Step 1, you should be fine. Step 2, so computer t-stat minus 3.3939. Critical t-stat, I didn't change the alpha, so the critical t-stat should be the same as the previous question 2.2, 2.567, but remember this is one-sided left tail test, so you must add the negative sign. So it becomes minus 2.567. And since the computer t-stat minus 3 point something is smaller than the critical t-stat, we reject the new hypothesis. Then meaning alternative hypothesis will take place, meaning when party hour increases, providing there's no change in study hours, remember the ceteris paribus condition again, and then on average, final mark would decrease in PRF. So meaning, just like the sample regression function, in the population regression function, the negative relationship between party hours and marks would also happen. Okay, happy with that? And then we can do question 3. Okay, now I want to focus on one-sided test, and then the hypothesized value would no longer be 0, actually. So let's do this question 3. Okay, sample size is 33, k is 2, so degrees of freedom is 32 minus 2 minus 1 constant, so 30. Okay, let's do the first one. Currently in the sample regression function, the slope parameter in connection with study hours, meaning B1 hat is 5 point something, which is greater than 4. So I want to know in the PRF would the true slope parameter B1 would be equal to or greater than 4 at alpha equals 10%. You spot the keyword greater than.